In this video, we will be talking about current, resistance, voltage, and Ohm's law. So again, I've structured my notes a little bit differently in this video. For the remainder of the school year, it is going to be your choice how you want to structure your notes, as long as they are in a focused notes format. And please remember to include the objective, the topic, the essential question, and a 1 to 2 sentence summary about what you learned from the video. So our objective for today is to be able to use Ohm's law to identify and calculate the current, resistance, and voltage of an electric circuit. And our essential question is, how do we use Ohm's law to describe current, resistance, and voltage of a circuit? That is the question you are going to be answering in about 1 to 2 sentences in the summary at the end of your notes today. So you all might be somewhat familiar with these terms already, but maybe not when we are using them in physics class. But the first term we are going to go over today is this thing called electric current. Now, current describes the rate or how fast an electric charge moves in an electric circuit. And I'll talk about circuits in just a moment, but what I want you all to think about is basically a wire, those circuits that are used to create your electronics, your phones. Your phones have a huge circuit board, or I guess it's somewhat small, but there's a lot of circuits in that circuit board that's allowing you to operate your phone. So when we talk about circuits today, that's kind of what we are referring to. So the current is how fast an electric charge can travel through a circuit. And remember, we talked about electric charge in the last video. It can be positive or negative. And remember, charge is measured in units of coulombs. We use that capital C for coulombs. Now, our variable for electric current is I. And I know that's not really, doesn't really make much sense, but we're going to use a capital I to represent electric current in our physics equations. Our unit of measurement, what current is measured in, is something called amperes. And we use a capital A to represent that unit of measurement, amperes. Now, you might be more familiar with the shorter term, which is amps. Okay, so we often, instead of saying amperes, we'll say amps. So the current of this circuit is 10 amps. That might be a more familiar term to you, but that is what we are getting at. That is how we measure current. Now, the direction of a current in a circuit is usually the direction a positive charge. Remember, we're talking about how fast an electric charge is moving. We depict and look at what direction that charge is moving in a circuit. It is typically going to follow the direction of the positive charge. And I will talk about what that means in just a moment once we get to an illustration of an electric circuit. But just note that whenever we're drawing the direction of a current, we are drawing it in the direction that a positive charge would move through a circuit. The next two vocabulary terms we have are resistance and voltage. So we'll go through resistance first. Resistance is the amount of opposition in the electric circuit to the electric current. So it's kind of exactly what it sounds like. Resistance is created by things called resistors. Resistors are devices designed to resist the flow of electric current. A great example of a resistor that we use pretty much every day in our lives is a light bulb. A light bulb is an example of a resistor. It creates a resistance to the electric current in order to turn the light bulb on and convert that electric current into light. Our variable for resistance is a capital R. So thankfully that one makes a little more sense. Resistance starts with R. So we're going to use capital R to represent resistance. And our unit of measurement is something called ohms. Now this is a really It's a new unit of measurement, but you might be familiar with ohms because we mentioned this in our objective for today when we talked about Ohm's law. So ohms is going to come back, but our variable we use for ohms is something called an omega. This is the omega sign. It is a Greek letter. So again, y'all are getting super familiar with the Greek alphabet at this point. I'm going to write, this is the Greek letter omega. So that is the symbol we are using to represent ohms, which measure the amount of resistance in a circuit. Finally, the last vocabulary term we're going to go over in this video, the main one, is voltage, right? So voltage is the amount of electrical potential energy between 2 points in a circuit. So think back to when we talked about types of energy. We said there's kinetic, we said there's potential, we said there was nuclear energy, we talked about chemical energy. All right, voltage is a measure of the potential energy between 2 points. So we are measuring electrical potential energy using voltage, but we want to know the difference. If we're looking at a circuit, we're labeling those 2 points on a circuit. We want to know the difference between the electrical potential energy of those 2 points in a circuit. That's what voltage is measuring. Now, you might be familiar with the word voltage because if you've ever used a battery or a generator, something of that nature, those devices produce a voltage. So you might say, oh, I have a 10-volt battery, or, those are things that produce voltage. So voltage, again, is a nice and easy variable to remember. We're going to use a capital V for our variable for voltage, and our unit of measurement is the volt. We measure voltage, the voltage of an object, in volts, and we use a capital V for that as well. So this might be the first time you all are seeing the same variable used, or same letter used for a term's variable, as well as its unit of measurement. So just keep that in mind. We're using capital V for the variable and for the unit of measurement when we are referring to voltage. So how does this all come together in an electric circuit? So within an electric circuit, well, let me back up. An electric circuit is defined as a path for transmitting electric current. So I want you all to think about in your lives when you have ever learned about electric current traveling through something. It's traveling through a path. What does it need in order to travel? This is what we are doing with an electric circuit. Okay, so we need a battery to create a voltage in order for that electric current to travel. I'm going to zoom in here. So this would be an example of a very, very simple electric circuit. So we have our battery. Remember, batteries, or if you are unfamiliar, batteries have a positive terminal and a negative terminal. So those batteries are actually, those have charges. There's a positive charge on the positive terminal, and there's a negative electric charge on the negative terminal. And that's going to affect the direction of the current through the circuit. So if you recall, when we talked about current, our current in a circuit travels in the direction a positive charge would travel in the circuit. So if we have a positive terminal and a negative terminal, and we're talking about the direction a positive charge would want to go in an electric circuit. Remember, like charges repel. This positive charge wants to get away from that positive terminal of the battery. So you're actually going to start to see the direction of the current in a circuit always goes from the positive terminal of a battery back around to the negative terminal. So that is the battery. It's creating our voltage. We also have resistors in our circuit as well. Like I said, a light bulb is a perfect example of a resistor. It creates resistance to the current going through it. So this is kind of what it would look like in real life. As physicists, we don't like to spend a ton of time creating a masterful piece of art. So we create a really rudimentary depiction of what a circuit looks like. So our battery has become this little break in the circuit, all right? But you can still see we've labeled our positive and our negative terminal on the battery. Now, when we talked about voltage being the difference between electric potential energy and 2 points, our voltage here is the difference between that electrical potential energy from the positive terminal of the battery to the negative terminal. So that's kind of where we get our voltage, is the difference in potential energy between these 2 points. I will put that there. So that's our battery. Again, we have a wire, which is a great, we talked about this, I believe, in the last video. It's a great conductor. Metal wires are great conductors for carrying charge. And remember, current is the measure of how fast that charge is moving. So we are going to see our electric current flow away from the positive terminal of the battery all the way around back toward the negative terminal of the battery. So I've labeled that direction of the current in a circuit in black. We also label our resistors. We kind of do a zigzag line to label the resistor. So that's just indicating, again, there's some resistance to the flow of charge in that circuit, which we're labeling with that zigzag line. Again, as that's taking the place of us having to draw a whole light bulb here. So that's our resistor in that circuit. Now, since circuits, we are labeling the direction of the current as a positive charge would move through the circuit, that is going to be the opposite direction of the flow of electrons. Remember, electrons are negatively charged. So I'm going to, just as a reminder, electrons have a negative charge. So the current is drawn in the direction that a positive charge would move through a circuit. The electrons are actually moving in the opposite direction. So I did want to point that out, that current is typically the result of electrons moving through the circuit. However, that current, the direction of the current, is actually going to be drawn in the opposite direction that the electrons are actually moving through the circuit, because those are negatively charged. All right, so moving on from that, let's put all of these concepts together and talk about Ohm's law. So this is a law, that a new scientific law that we are learning today, but really what it boils down to is just this equation. So this equation states that the voltage at any point in a circuit is going to be equal to the current at that point in the circuit multiplied by the resistance. So Ohm's law is V equals IR. That's kind of how we state that. This is a nice equation. We've got 3 variables. 2 of them are being multiplied together. So we can actually use our triangle trick. So remember, when we set up our triangle, whatever variable is on its own side of the equal sign is going to go at the top of the triangle. The 2 variables that are being multiplied together, so I'll draw a little multiplication sign here, they are going on the bottom next to each other to indicate they are also being multiplied together there. Whenever we are using our triangle trick, you're going to take your finger or your hand, cover up one of the variables on the triangle. That is what you will be solving for in the problem. So we'll go through an example now showing you all how to use this triangle trick for Ohm's law. I'm going to zoom out just a tad. Not that much. All right, so we've got an example here. It says an electric circuit has a 200 ohm resistor and a current of 5 amps. What is its voltage? So we've drawn a really simple electric circuit. I'm going to add a couple more labels here. I'm going to zoom in. And we will label. And I'm going to add some different colors here. Okay, so we see that it has a 200 ohm resistor. Here's our resistor on the circuit. Remember, it's that zigzag line. Those are all of our resistors. So I'm going to write that this is 200 ohms here, 200 ohms of resistance. All right, we also know that the current, and I will move this over, it says it has a current of 5 amps. So I can draw our direction of the current through the circuit. It goes through the resistor and back to the negative terminal of the battery. So our current is 5 amps. What we do not know, what we are solving for in this problem is the voltage. So we want to know what the voltage is equal to in this problem. All right, so that is my step number 1 when solving a physics word problem. We will move on to step number 2. All right, step number 2 over here. Make your T-chart of what you know and what you don't know. So again, I'm going to just quickly write. We know that there is a resistance. We're using R for resistance of 200 ohms. We know that the current, and remember this is the tricky one because we're using a capital I for current as our variable. Our current is equal to 5 amps. And we know we are solving for the voltage. We don't know what the voltage is yet. Okay, moving on to step number 3, let's go ahead and set up our equation. Again, we will use that, I'll go over that triangle trick very briefly. This is our triangle using Ohm's law. So V is going to be at the top. We'll put I and R at the bottom. And we know that we are solving for V. So with your finger, with your hand, go ahead and cover up what you are solving for in this triangle. That's our V. So cover that up. We're going to write this here to indicate we are solving for V. We don't know what V is yet. Cover that V up with your hand or your finger on the screen. And you will see now we are going to be multiplying I times R. So we're using our equation V equals IR to solve for the voltage of this circuit. All right, now we are ready to plug this in. So moving on to step number 4, I'm just going to rewrite our equation here. V equals IR. I'm going to rewrite V again to indicate we do not know what that is equal to yet. We can plug our number in for current, right? We do know what current is equal to. So I'm going to write current is equal to 5 amps, right? That we are multiplying times the resistance, which we know is equal to 200 ohms. You can go ahead and plug that into your calculator, and you should get that the voltage of this circuit is 1,000 volts. And that is how we use Ohm's law in an example problem with an electric circuit. All right, so I hope this video was helpful for you all in understanding these concepts of current, resistance, voltage, and how to put them together using Ohm's law. Again, please remember to write a 1 to 2 sentence summary answering that essential question. And I look forward to discussing with you all in class.